Interval notation is a really nice tool that we have that lets us express a portion of the real number line using a very shorthanded notation. So the way it works is like this. If your interval that you want to express starts at A and ends at B, then you'll write A comma B. And depending on whether you want to include the endpoints or not, you'll either use brackets or parentheses. If you want to include the endpoints on the left or right, you'll use a bracket. And if you don't want to include the endpoints, you'll use a parentheses. And you don't have to use both of them. You don't have to use brackets at both endpoints or parentheses at both. You could use a bracket on the left endpoint, but a parentheses on the right. And so this will give you all the values from A to B in the middle of A and B, and we're going to include the endpoint A, but not include the endpoint B. So these are really, really helpful, especially for things like inequalities and things like that. Here's an example. Let's say we have all the x's greater than or equal to -1. So I know what this would look like on a number line, but number lines can be kind of big, and it's a graphical picture of where these numbers are. So if we put it on a number line, we would put -1, and because this is or equals to, we'd put a closed dot, and then we would shade in all the points to the right of -1. So this is expressing this same numerical set, the same set of values as x greater than or equal to -1. But an alternate way of writing that would be, this is the set of numbers starting at -1 and going to infinity. Because notice we don't stop ever. It continues on until we get to infinity. So now all we have to do is put the brackets or the parentheses. Again, since this was or equals to, we're including that endpoint right there, which means we'll put a bracket on the left-hand side. Now, something peculiar about infinity. Infinity, obviously, by definition, is not a finite number that you can get to. So because we can never reach infinity, we're going to always put parentheses anytime we see an infinity or negative infinity. So this is interval notation for this inequality or this segment of the number line. And it's very nice and compact. It's a very good notation to use. All right, let's close with one last example. Here we have a linear inequality that we can solve, and I want to express my answer 3 different ways: with an inequality, a number line, and an interval notation. So let's start with the inequality form first. We're just trying to solve for y. Basically solve these guys the exact same way that you would an equation. Just remember, if you ever have to multiply or divide by a negative, we have to flip the inequality around the other way. So we'll subtract 3 from both sides. We'll get -4y is greater than or equal to -24. And I did not have to flip that inequality because I just subtracted 3. I didn't multiply or divide by a negative. But now I need to divide both sides by -4. And so because I'm dividing by a negative, then I'll have to flip this inequality around, and we'll write it as y less than or equal to +6. That's -24 divided by 4. So the inequality way of writing the answer would be y less than or equal to 6. Now, as far as the number line goes, that's relatively simple as well. If here's our number line, and this number line represents y, then we go to 0, 1, 2, 3, 4, 5. Here's 6. We'll plot 6. Since it's less than or equals to, that means we're going to do a closed dot, and then we're going to shade in the y values less than 6, or the ones that are before 6. Now, last one, interval notation. I'm getting all the values starting at -infinity up to 6, and then we stop. So we'll go from -infinity up to 6. We include 6 because it's or equals to, so there should be a bracket on this side. But again, since we have infinity on the left and you can't actually reach infinity, it's not a finite number, we're always going to put parentheses for anything dealing with an infinity. So this is 3 equivalent ways of saying the same answer. So all of these are really good at expressing a large quantity of points in a very condensed type of notation. All right, now the last thing I just want to stress one more time is the fact that plus or minus infinity always get parentheses. So I think we've already talked about that. So anyways, that's just a little bit about interval notation. So hopefully that helps you better understand it.